we're going to start this next video by talking about scientific notation. There's a giant little informational box here on the definition. But I think most people have seen scientific notation, so I'm going to kind of slide past this. This information is here if you want to read it, okay? It gives a lot of good information. And then we'll be kind of doing it. But the main idea is that scientific notation looks like this. It's a number between 1 and 9, 1 and 10, not including 10, right? It's a single digit and then with decimals. Single digit and then decimals. And then times 10 to some exponent. That's what scientific notation is. And it's just a really standardized, concise way of expressing really big or really small numbers. Okay? So how we're going to convert it is we're going to look at it. So there's two parts to scientific notation, A and N. A, that's that number between 1 and 10. And N is how many zeros we have to move the decimal place, how many places we have to move the decimal place. Let's just do an example and then try to make this a little bit more clear. So we have example 614, and we want to convert 8,150,000 to scientific notation. So remember that all scientific notation is some number A times 10 to the nth. So the A is going to be a number between 1 and 10, not including 10. So A here is going to be 8.15. So it's always just going to be the first digit, point, the rest of the significant figures. We won't talk about significant figures, but if you do know what those are, that's what we're doing here. So 815, we don't need to include these zeros. Only need to include these zeros if there's something after them that's not a zero. Okay, so that's our A, 8.15 times 10, and then the question is, what's the N part? And so what we do is we count how many times do we have to move the decimal point. So the decimal point is starting here, and we're moving it all the way up to here. Let's count that. 1, 2, 3, 4, 5, 6. Because we had to move it, the decimal place, 6 places, there's going to be a 6 here. The last question is, should the 6 be positive or negative? Which way are we moving the decimal place? A positive exponent is going to be a bigger number in this case, right? 10 to the 6th. That's 10 times 10 times 10 times 10. A negative exponent, remember negative exponent means we're dividing. It's getting smaller. So because this is a big number, it takes a big exponent to get us there. Is one way of doing this problem. So this is going to be our final answer. There are other ways in that box, in the notes, of rationalizing the process, but this is how I approach it. Any way that makes sense for you that's also correct is good. Next up is going to be 0.0000245. So again, all of these zeros, they're not part of our A. Our A is just that number 2.45. Okay? It has to be a number between 1 and 10, so it's going to be 2.45 times 10. The question is, how many times do we have to move the decimal place? The answer is 1, 2, 3, 4, 5, 6, just like last time. Notice these are very different though. This is a big number, this is a small number, very close to 0. We're going to need a negative exponent this time because we're dividing by a bunch of 10s in order to get here. Okay? In other words, if you're moving the decimal place right, negative exponent. If you're moving the decimal place left, you're going to have a positive exponent. All right, in order to get there. But again, there's a lot of different ways of thinking about that. Find the way that makes sense to you. Okay, and again, don't hesitate to go back here for reference. I'm skipping this because it's a lot of information and some people have seen scientific notation before, but the material is here if you want it. if it is helpful for you. All right, next we're going to go the other direction. So example 616. We want to convert 5.23 times 10 to the fifth to standard notation. Well, this is just going the opposite way, right? We have 5.23, and we're moving the decimal place 5 times. It's 10 to a positive exponent, so this is getting bigger. So the decimal place has to go to the right in order to make 5.23 bigger. 5 times. 1, 2, 3, 4, 5. Zeros go here. So this becomes 523, 0, 0, 0, and all that's left is figuring out where the commas go. Commas go every 3 digits starting from the right. So 523,000. And you can kind of check your answer on both of these, right? You can try to put this in scientific notation and hopefully you get this again. Here we could check our answer by multiplying this out, doing what we just did, right? If you wanted to, you could check our answer here, say 8.15, 10 to the 6, we're making it bigger. The decimal place is going 6 to the right. 3, 4, 5, 6. Fill these in with zeros. We have 815, 0, 0, 0, 0, commas, 8.15 million. Good. So you can always go both ways on these to make sure that you're doing it correctly. Last example for this video is going to be 717, 6.17. That's going to be 4.25 times 10 to the negative 4. Negative exponent is going to mean we're dividing. Negative exponent's making this smaller. So we have 4.25, 4 decimal places to the left now. 1, 2, 3, 4. We're going to add zeros. And remember the decimal place is here now. So we only add 3 zeros. So this is going to be 0.000425. But it's very normal. Not everybody does this. So this is a correct final answer. But it's very normal to write a 0 before the decimal point. So I will accept either one of these. But I prefer the one on the bottom. But I'll take either. I'll take either. Okay? And that's how it's done. If you're a little shaky on this, you can maybe wait to do the homework. Or you can start it and check your answers with my answers that I posted. Or you can go on to the next video. We'll be doing some more of this in the next one as well.